Problem number 12. Consider this function. A is an unspecified constant. For which values of a does the graph of f have a vertical asymptote? So vertical asymptote means that the limit as x goes to some particular value is, plus or minus infinity here. And so we get those in a case like this by dividing by 0. So the issue is going to be the limit as x goes to 2 from either the left or the right of this expression here, ax minus 6 times x plus 1 divided by x minus 2. So what happens if we plug in 2 into the denominator? We get 0. And we plug in 2 into the numerator, we get a times 2 minus 6 times 2 plus 1. And the thing is that to have a vertical asymptote, and the vertical asymptote would have equation x is equal to 2. There would be an equation of the vertical asymptote exactly when so we have this as long as the numerator is not equal to 0. We have this as long as the numerator is not equal to 0. 2 plus 1, that's 3. That's not going to be 0. We want 2a minus 6 to not equal 0. And so that is a is not equal to 3. So the answer here, for which values of a does our graph have a vertical asymptote? It will have a vertical asymptote as long as a is not equal to 3, and the equation down there is x equal to 2. If a is equal to 3, then our function is, like this would be the limit as x goes to 2 from like the right or the left of 2x minus 6 over 2 plus, so x plus 1 over, all times x plus 1 over x minus 2. Sorry, not 2, 3 there, 3x minus 6. But 3x minus 6 is equal to 3 times x minus 2. And so those factors of x minus 2 would cancel out. This would be like the limit as x goes to 2 of 3 times x plus 1. And that's just going to be what? 9 here. That is defined. We aren't getting infinity here. So a is not equal to 3. As long as a is not equal to 3, you get x equal to 2 as a vertical asymptote. Okay, so for part B, we're asked about horizontal asymptotes. So we have to think about the limit as x goes to infinity, or the limit as x goes to negative infinity of this expression here. Let me distribute out the multiplication upstairs. Limit as x goes to infinity of ax squared minus 6x plus ax minus 6 over x minus 2. And so this is going to be, it looks like the degree upstairs is bigger than the degree downstairs. And so this limit here, it sure looks like, let's divide top and bottom by x to make this even more striking here. To get the limit as x goes to infinity of ax minus 6 plus a minus 6 over x over 1 minus 2 over x. So as x goes off to infinity, the denominator goes to 1 minus 0. It's just 1. That will go to 0. That will be a. That will go to 6. And then this term will go off to infinity, or negative infinity, depending on the sign of a, except when a is equal to 0. So a is not equal to 0. If a is not equal to 0, then this is going to equal positive infinity or negative infinity, depending on whether a is positive or negative. But if a is equal to 0, that term goes away. That term also goes away. And the limit here is equal to negative 6. and that gives you a horizontal asymptote. So what is the answer here? For which values A does f have a horizontal asymptote? Only when A is equal to 0, because that makes the degree of the numerator and denominator both be 1. If the degree of the numerator is larger than the degree of the denominator, you're not going to get a horizontal asymptote. Okay, so that takes care of it. I only did the limit as x goes to infinity. Technically, you should also check the limit as x goes to negative infinity, but you'll get the same answers.